All right, our next speaker, Miryang Jung, is a front-end engineer at a tech company. They are going to be sharing with us about how to enhance form usability through UI changes to help reduce complexity for developers.
Hello, my name is Miryang, and today I'm giving a talk titled Enhancing Form Usability Through UI Changes, Reducing Complexity. I work as a front-end engineer at a company called Grand Clip in South Korea, and this photo was taken in Bangkok last year. Actually, I love Thailand so much that I visited 5 times just last year. And one day my dream is to work here in Bangkok. So that's why giving my first global conference talk in this city was nerve-wracking and exciting for me. I'm very nervous. Okay, today I'll be talking about how we improve the user experience of a complex product registration form. To give you the conclusion first, we redesigned the form to help users easily understand what's needed and make selection quickly. This is more about the decision the product team can make to solve problems rather than a technical discussion, so feel free to take it lightly, please. Okay, the original product registration process was designed as a multi-step form spread across 4 pages. Each page had around 10 input fields, and selecting a field would open a bottom sheet for option or direct input. We also had validation check at each step, allowing users to proceed only after filling in all required field. This design had 2 main intentions. The first was to reduce cognitive load by letting users enter information step by step. The second was to keep the UI clean by organizing input across multiple pages. But however, in reality, this form had many issues, many problems. The first issue was that users couldn't see the entry process at a glance. First time users struggled to understand what information was required. Just from the first page, they didn't know what information they had to enter next. So sometimes they filled in details too soon that weren't needed yet. The second issue was that the interaction was tiring for users. The automatic focus, shift, and bottom shifts disrupt the input flow instead of helping. Users had to go through repetitive actions, make the process frustrating. The third issue was that it was difficult to edit previous entered information. To modify an earlier entry, user had to go back multiple steps. It was also hard to remember where specific information was located. So the first issue was increased development complexity. Even though we use Jode for validation, handling required build and page transition was scattered across the codebase. Debugging took too much time, and fixing bugs became unnecessarily difficult. From user feedback, we identified 2 major pain points. The first was, even if I just want to edit one detail, I have to go through multiple pages. It's annoying. The second was, I wish I knew in advance what information I needed to prepare. So to solve these problems, we made several key improvements. First, we placed all input fields on a single page so that user could see everything at once. Second, we removed bottom seat and displayed options directly for better visibility. Third, we provided default value to make input easier. Fourth, we use colors and icons to help user quickly recognize and select options. Finally, we simplified technical terms to make the form easier to understand. For example, let's look at selecting a color and gemstone. In the old form, user had to tap a button, wait for a bottom seat to open, select a color, close the seat, wait for another bottom seat to open, and then select the gemstone. In the new form, the process is much simpler. User can now choose a color, scroll a little, and pick a gemstone, making the process much easier. To make sure everything worked well, we also introduced component testing. Using bytest, we added tests for individual input components, and the form was at whole. This made it easier to automatically check the UI changes work correctly. While doing this, we also split components into smaller parts, improving the code structure. As a result, components become more reusable and easier to maintain. Testing important cases like required build validation and error messages also become much simpler, which help the entry team work faster. After this change, we saw great improvements. There were no more user complaints about product registration issues. The registration process became faster, and the number of registered products doubled. The code becomes simpler, make it easy to fix bugs and new features. It might seem like small changes, but it made a big difference for our team. Our team realized that if we can't make everything perfect, it's better to focus on a simple and easy to use interface instead of making it look fancy. We made a product-driven decision to simplify the UI, as it was a more effective approach. This allowed us to achieve a better outcome while saving both time and resources. Of course, this process also helped us grow technically. Through this improvement, we introduced form testing as a new technical challenge, which allowed our team to take our skills to the next level. I'd like to end my talk by sharing another example of a similar decision we made. This case is about a pickup schedule selection form. There were two main issues with this form. First, the selection was restricted to days within 2 weeks. Because of this, year selection was only needed in December. From January to November, the year selection was completely unnecessary, yet the UI still displayed it. Second, even though the month and time selection had limited options, the roller style UI made it difficult for users to quickly see what choices were available. Technically, we could have solved gesture conflict by handling event propagation, but however, since there were multiple issues, we decided to improve the UI instead. We changed the interface to a grid style so that user could immediately see all available options. we also replaced the roller with buttons to prevent accidental UI closure and make the selection process clearer. So thank you for listening. Yeah.
We've got time for some quick questions. Any questions? All right. I've got a question. So you said you used Vitest. So was Vitest a new component that you added on top of the UI design as well, the redesign?
Am I design? Yes.
Oh, okay. Vitest is very helpful, like the test-driven development.
Yes.
Yeah. Alright, let me check the next speaker. Oh, okay.
About the form validation part.
Use the microphone so online people.
Can you go back to the slide where it was close to form validation? I'm not sure it was really form validation. It was at the beginning, I think. It was about keeping the button disabled until the value was correct, something like that. It was earlier.
Here?
Earlier.
Huh?
Earlier.
Oh,
Yeah, here.
Here? Here.
Yeah, here. So on the right, on the list, we say when first entering, the register button is disabled, right?
Yes.
If the value is valid, the register button is enabled. If the value is invalid, the register button remains disabled. By invalid, you mean, what do we mean by invalid and valid here? Because like, if it's invalid, how do I know why it's invalid? I don't know if my question, it's actually, might be just very basic. I don't know, I'm just asking.
Yes. Each step pages has required field.
Yeah.
Because we have 4 step pages. So value is spelled is for required field.
Right.
Yeah.
Okay.
Yeah.
So my question was more like, if I put a value that is wrong, do I wait for, submitting the form, or do I show directly that it's wrong? Or I just disable the button? I'm not sure. What's the best approach here?
I think show error message under the input field.
Before I try to submit, right?
Yes.
Directly, okay.
Yeah.
Okay.
Who's the next speaker? Are you here? Thank you.
Thank you.